Thank you. So good morning. So this is the video lecture on data structures. So we are currently discussing with module 5, that is searching and sorting. So in yesterday class we have seen with types of sorting. First we have seen heap sort, and second one is radical sort. Now you come for the some applications of the heap. Okay, so where the heap sort is been applied and where you have used, so where you are going to apply, that you will see in today's class. So in today's class we will go with concepts like applications, second one left east heap, and the third one extended binary tree. Okay, so three concepts we will be discussing today. So very important concepts for exam point of view. So application of heap data structure. So where you are going to use heap. So for that, now we shall see. So we have seen what is heap, what is minimum heap, what is maximum heap. So minimum heap means when the parent is lesser than child, we call it as minimum heap. If the parent is greater than child, we call it as maximum heap. Okay, so now we come for the heap sort technique. So heap sort technique will run according to swapping technique. Okay, so swapping. So where you have come across this heap sort, so it is been applied in situations. So first we shall see. So heap sort as limited users. So that means its use is limited. So there is no more much applications where you come across heap. So it's of only limited users because quick sort is better in practice. So quick sort is the another sorting technique we have. So compared to heap sort, quick sort is better. So that's why we consider heap sort is of limited use. Okay, so heap data structure is enormously used. Heap is used, but heap sort is of limited use. So some of the examples or uses of heap sort are, first we are going to use it in priority queues. So priority queues can be efficiently implemented using binary heap. So using which heap? Binary heap, because it supports which operations? Insert, delete, decrease key operations in big O of log n time. So that means why you are using heap for the priority queues? Because it supports insert, delete, and decrease the key operations in log n time. So binomial heap and Fibonacci heap are the variations of the binary heap. So binomial means you know the binomial coefficients. So what is binomial coefficients and Fibonacci heap. So Fibonacci heap means how you generate the Fibonacci series. So we generate the Fibonacci series. So you generate Fib series. So Fib series first you will get, Fib series first default numbers are 0 and 1. So next series you will get 1. That means how you get this one? By adding 0 and 1. So 0 and 1 will get you 1. Next you add two numbers. So two numbers are 1 and 1. So 1 and 1 will get you 2. So 1 and 2 will get you 3. 2 plus 3 will get you 5. 3 plus 5 will get you 8. 8 plus 5 will get you 13. So 13 plus 8 you will get 21. So this is the sequence of numbers you are having. So for that, which are the default numbers? So default numbers are 0 and 1. So all these numbers will be stored in the form of the heap. So that heap is called as a Fibonacci heap. Okay, so which are the variations of the binary heap we are having? One is the binomial heap, the other one is Fibonacci heap. Okay, so now that is the applications. Okay, so where you come across the applications of heap data structure, one is in priority queue. So using what you do in priority queue. So using heap, we can do insertion, deletion, and the key operations in log n time. Okay, so other than that, it is also used in binomial heap and Fibonacci heap. Okay, so these are the applications of heap data structure. So that is the first topic what we will be seeing. Now you come for the second topic. So second topic is called leftist heap or leftist tree. Okay, so according to the binary, you come for a binary tree. Okay, so binary tree, when you tell it as a binary tree, when left child is lesser than root and right child is greater than root, so now we call it as a binary search tree. So we call it as a binary tree when it has two children. So if a node contains two children, it is called binary tree. So when you call it as a binary search tree, when the left child is lesser than the root and right child is greater than the root. So at that time we call it as a binary heap. Okay. So now you come for the concept leftist tree. So leftist heap or leftist tree. So come for the scenario, every node, so every node has a value. Okay, so binary tree, a leftist tree may be very unbalanced. So leftist tree will be very unbalanced. So any tree is called leftist tree with the following properties. So what is the first property? So it is first you should have min heap property. So when you call it as a min heap, so parent is lesser than children, we call it as a minimum heap. So that can be taken as key of I is great. Key of I means I is the children. So is if the I children are greater than or equal to parent, we call it as min heap. Or you can also tell parent is less than or equal to child. Parent is less than or equal to child, or child are greater than or equal to parent, we call it as min heap property. Okay, so now that is the first property. So where your leftist tree is a binary tree with first one min heap property. So min heap you can tell it as K of I is greater than or equal to K of parent. That means children are greater than or equal to parent. So second one, heavier on the left side. So keep in your mind. So what you have in the min heap or max heap. Okay. So min heap and min heap means the parent will be lesser than children. Okay. So children you may have left child as well as right child. So heavier on the left side. So on left side it will be always less. On right side it will be always more. So keep this one in your mind. On left side you will be having always less and right side you will be having more. So that one we consider it as min heap property, but you see here if it is heavier on the left side, that means so distance of left is greater than distance of right. That means you can tell it as right is less than or equal to left. So actually what will be the case? Initially left will be lesser than or equal to right, but in left is steep, left part is greater than right part. So see the scenario here. You are having two. Left part you are having one. Right part you are having one. So this is property for what? Minimum heap. So minimum heap means so parent node will be lesser than child node. So second property is left will have higher data than right side. So keep that one in your mind. So your dist of I is the number of edges from I to j. Okay. So how you tell that we shall see with the example here. So leftist tree, you can see on left part you see. So here you see on left it is 0, On right also 0. But here you can see this is a leftist tree. On left is 1, on right is 0. That is left is greater than or equal to right. So is it one? It is left you are having 1, right you have 0. Here also you can see left you are having 1, right you are having 0. So similarly here you can tell it as, so at that time we call it this one as leftist heap. So leftist heap means, so left part will be having more, will have the greater data compared to right one. So that one is called as a leftist heap or leftist tree. Okay, so now you can see here from the above second property we can draw two conclusions. The path from root, which is the root here, 2 is the root here. So root to rightmost leaf is the shortest path from root to leaf. So if you can go with the rightmost leaf, which is the rightmost leaf, so this is the rightmost leaf, it is the path is 1. So that you can go, the path from root to rightmost leaf is the shortest path from root to leaf. If the path to rightmost leaf has x nodes, then leftist heap has at least, if the path to rightmost leaf, which is the rightmost leaf, it can be this one or it can be this one. So because you have to go with the right part. So this is the left part. So this is the right part. From root to rightmost leaf. So rightmost leaf is this one or this one. This one is left, this one is left, this one is left. So that's why we can tell it is the shortest path from root to leaf. So if root to path to rightmost leaf has x nodes, then leftist heap has 2x minus 1 nodes. Okay, so this is the operation what you can tell leftist heap or leftist tree. So now you come for the next topic, that is extended binary tree. So when you tell it as a extended binary tree, so any binary tree in which all the subtrees of the original tree are replaced with the special nodes called external nodes. So whereas other nodes are called internal nodes. It's a type of a binary tree in which so extended binary tree is a type of binary tree in which all the subtree of the original tree or subtrees of the original tree are replaced with the special nodes called external nodes, whereas other nodes are called internal nodes. So subtree of the original tree, 20 minutes. Subtree of the original tree are replaced with the special nodes called external nodes, whereas where we replace with the special nodes are called external nodes, and replaced with the external nodes, whereas other nodes are called internal nodes. So you can go with this particular diagram. So here the circles represent internal nodes. So which are the internal nodes? So what are all the things you are having in the circle? So that one we call it as a internal nodes, and boxes. So boxes represent the external nodes. So which are the external nodes? What you are having all the leaf nodes. So here you can see here. So here it is the right child. So here it is left. So all these are called as a X. All these boxes represent external nodes and circles will be represented with internal nodes. So that are called as a extended binary tree. So what are the properties of extended binary tree? So the nodes from the original tree are internal nodes. So first property you come, the nodes from the original, this is the original tree. Okay, so nodes of the from the original tree are internal nodes and special nodes are external nodes. All external nodes should be leaf node and all internal nodes should be non-leaf. So you can see here, so all these are boxes means external nodes. All external nodes are the leaf nodes. So those all internal nodes are non-leaf because it is having one or two children. So that's why we tell it as the things with circle are also called as a internal nodes. Those are the non-leaf nodes. So every internal node has exactly two children. Internal node you can see. So internal node is 5. It is having two children. 2 is having 2. 1 is having 2. 3 is having 2 and 4. So every internal node has two children and every external node is a leaf. Okay. So where you have, that is the properties of extended binary tree. So come for the applications. So where you have come across this extended binary tree. So it is extended binary tree is used to calculate for weighted path length. So weight path from root node to leaf node. So which is the leaf nodes you are having here? So it is 8, 9, 9, 6, 10 and 12. So these are the leaf nodes you are having. From root node to leaf node, you have to calculate the path. So that's when we call it as calculate weighted path length. It is used to calculate total path length in case of weighted tree. So here you can think of this one. So first you are having what is the weighted path. So for 8, next you go with 9, next 9, 6, 10, 12. What are the values you are having? You put it here. So total path of the leaf node. So which are the leaves? So first you put 8 here. So you can place any values like this. Okay. But the thing is, it should obey the property of binary tree. So here 1 is there, 2, 3. So you can give any values like that. Okay. So now you find the path from root node to leaf node. So first leaf node is 8, second leaf node is 9, third leaf is 9. So next you get 6, 10 and 12. Now you come for the level. So 1 is at level 0, 2 and 3 are at level 1. Next 5. So 5, 9, 6, 4 are at level 2 and all these are at level 3. So this is level 3, level 2, level 1, level 0. So root will start at level 0. So 2 and 3 are at 1. This one is at 2, this one is at 3. So now you multiply it with level. So first 8 is at level 3, 9 is at level 3. This one 9 is at level 2, 6 is at level 2, 10 is at level 3, 12 is at level 3. So when you calculate what is the path you are having, it is 147. Okay. So this is the weighted path length. So it is used to calculate total path length in case of weighted tree. So here the sum of the total weights is already calculated and sum of the total weights. So sum of the total weights is already calculated. So how you calculate the weight? So that I can tell it here. So here all the boxes are empty. Okay. So from root to this one, you can give the weight. So how you get this value gate? So it is 5 plus 2 plus 1. So 5 plus 2 plus 1 is 8. So similarly, how you get this one? 5 plus 2 plus 2. So 5 plus 2 is 7, 7 plus 2 is 9. So come for this one, 5 plus 4 is 9. So this one 6 plus 0 is equal to 6. So then you get this one, 6 plus 1 plus 3. 7 plus 3, 10. Next, 6 plus 1 plus 5, you get 12. So that's why that is the external nodes how you find. So total sum is already calculated and stored in the external nodes, and thus make it easy to calculate the path length with the weights. Okay, so it is another application is to convert binary tree into complete binary tree. So when you tell it as a complete binary tree, so when each and every leaf node is at same level, so we call it as a complete binary tree. So all the leaf nodes you can see, all the leaf nodes are at maximum complete are at the same level only. That's why we take it as we complete the binary tree into complete binary tree. So having removed all the external nodes is not complete binary tree. If you remove all these external nodes, it won't be complete binary tree. So in order to make it complete binary tree, you introduce external nodes. So external nodes are leaf nodes. External nodes are added onto it. So heap is the great example of the complete binary tree, and each binary tree is expressed as a heap if external nodes are added to it. Okay, so this is the concept on extended binary tree. Okay, so now you come for the review questions. So what is the conditions for max heap? So when you tell it as a max heap, anybody in the class? So what will be the condition for max heap? So whether you have parent is less than children or parent greater than children. Max heap means anybody can answer in the chat box. Max heap means no. So come for the max heap condition here. So here you can understand. So if the parent, you see here, min heap means parent is having lesser value than children, we call it as min heap. If the parent is having greater value than its two children, we call it as max heap. So that is the questions what we have seen. If the parent is greater than children, it's called max heap. If the parent is lesser than children, it's called as a min heap. So when you call it as a leftist tree, so we call it as a leftist tree when it is, you come for this particular condition. So first condition is it should satisfy min heap property. So min heap means parent, the children are greater than or equal to parent. If that, so that means parent is less than children. So we call it as min heap property. And second one, we call it as leftist if distance of left is greater than distance of right. So if the distance of left is greater than distance of right, we call it as a leftist tree. So next you get extended binary tree. So extended binary tree means, so all subtrees of the original tree are replaced with the special nodes, then we call it as external nodes, whereas other nodes are called as internal nodes. So come for properties of the binary tree. What are the properties? Original tree are called internal nodes and special nodes are external nodes. All internal nodes are non-leaf and all external nodes are leaf nodes. So every internal node has two children and every external node will have is a leaf. So external nodes are represented with the boxes, internal nodes are represented with the circles. So this is up to some of the review questions what we have seen. And these are the books we have referred this for this particular heap sort technique. So I hope you understood with this particular lecture. So this is up to today's class. So we have kindly, all these videos will be uploaded in your YouTube channel. Kindly click the bell button and click and comment on the videos by going through subscribing for the channel. So I hope you understand and subscribe for that channel and make it useful for the students. Okay, so I will be ending this particular video session here. So thank you all.